The National Communications Network, in collaboration with the National Center for Resource Development and the Ministry of Education, present CXC in Focus, a focus on the key subject areas of mathematics and English for students preparing to write the exams.
Welcome to our fifth lesson, CXC Mathematics in Focus. In this lesson, we will factorize algebraic expressions. First, let us look for the common factors in the terms of an expression. We have to look for the highest common factor among the terms. Consider this expression: 4ax plus 6ay plus 8az. Note that 2 and a are common factors of the expression. However, the HCF is 2a, and the expression can be written as 4ax plus 6ay plus 8az is equal to, take the common factor out, so we have 2a into 2x plus 3y plus 4z. Here is another example: 20x cubed plus 5x. The highest common factor is 5x. The expression 20x cubed plus 5x can be factorized as, extracting the common factor 5x, it is written as 5x into 4x squared plus 1, because if we divide 20x cubed by 5x, we'll have 4x squared, and if we divide 5x by 5x, we have 1. Let us now examine how to factorize the difference of two squares. First, let us look at how the difference of square is combined. We have x plus 1 times x minus 1. When that is worked out, we'll end up with x squared minus 1. We'll look at the details a little later. Here on this table, we have on the left-hand column expression, on the right-hand column factors. 4x squared minus 9. We must recognize the difference of two squares here. That is, the first term would be 2x all squared, and the second term 3 squared. So if we take the square root of 4x squared, we'll have 2x. If we take the square root of 9, we'll have 3. We can write the factors as 2x minus 3 and repeat that, but this time we'll change the minus to plus. So we'll have two factors. 4x squared minus 9 can be factorized as 2x minus 3 times 2x plus 3. Similarly, for the second one, we have 16 minus x squared. We must recognize that 16 is the same as 4 squared minus x squared. So we have the difference of two squares there. That is 4 squared minus x squared. The principle would be to find the square root of 16, and that is 4. Square root of x squared is x. So the first factor is 4 minus x. The second factor would be 4 plus x. So we repeat the first factor, but this time we change the sign from minus to plus. Let us look at the third example. A quarter minus y squared. Many students do not recognize that a quarter is a perfect square, because a quarter If we take the square root of a quarter, it is a half. So we have a half square minus y squared. So the square root of a quarter is a half minus the square root of y squared is y. So the first factor would be a half minus y. The second factor would be a half plus y. So a quarter minus y squared can be factorized as a half minus y times a half plus y. Let us look at the fourth example. 121a minus 49a cubed. If we look at these two terms, they are not perfect squares as they stand. We have a common factor between the first term and the second term. The principle is to extract the common factor first. If we extract the common factor, which is a, we will have 121 minus 49a squared. 121 is a perfect square because the square root of 121 is 11. So we have the first factor. In this case, we'll have three factors. The first factor being a, and then we factorize 121 minus 49a squared, and we'll have square root of 121 as 11. Square root of 49a squared would be 7a. And the third factor would be 11 plus 7a. So 121a minus 49a cubed can be factorized as a into 11 minus 7a times 11 plus 7a. Let us look at the fifth example, similar to the fourth. We have 20x cubed minus 5x. If you look carefully, you would see that the common factor is 5x. So if we divide 20x cubed by 5x, we will have 4x squared. If we divide 5x by 5x, we'll have 1. So we will have 4x squared minus 1. And then if you find the square root of 4x squared minus 1, it will be 2x minus 1, 2x plus 1. Note a correction to the answer given on the right side. So 20x cubed minus 5x is equal to 5x into 2x minus 1 times 2x plus 1. Let us factorize trinomial expressions. A trinomial expression is an expression consisting of three terms. Here's the example. Y squared plus 2i plus 1. One way of factorizing this would be to take the square root of y squared, and that would be y, and y will appear in both factors. Then we take the factors of 1. When you multiply, you will get 1, and then you would see we'll apply this mnemonic foil to see how we can verify the answer. In an expression as you see there on the right, y plus 1 times y plus 1, f will refer to the first term in each factor. The first term being y for the first, y for the second. O refers to the outer terms. In this case, the outer terms being 1. I will refer to the inner terms. The inner terms being the second term of the factor, which is 1, and the first term of the second factor, which is y. L will refer to the last terms, that is, the first term of the first factor and the last term, it is the last term of the first factor and the last term of the second factor. We can use this beautiful diagram to explain the same principle of FOIL. First term, if you follow the eyebrow, the first eyebrow, y times y times y will give us y squared, which is the first term on the left hand side. And you use the other eyebrow, it will be 1 times 1, which will be 1, which is the third term on the left hand side. Then if we follow the chin, that will be y times 1. Y times 1 is y, and that must be combined with the nose. 1 times y, which is y. So 1y plus 1y will give us the middle term, which is 2y. Here are some examples. Y squared plus 12y plus 35. We factorize this way. Two factors of y squared will be y and y. So the two factors will carry y. Two factors of 35 would be 7 and 5. You look for two factors of 35 that when you add them, you will get 12 in this case. So you will end up then 35 is the same as 7 times 5. And when you add 7 to 5, we get 12. So if we apply that phrase a moment ago to the right-hand side, you'll find that y times y will be y squared, which is on the left. 7 times 5, which will be 35, which is the third term on the left. And the nose, 7 times y is 7y, and the chin, y times 5, which is 5y. 7y plus 5y will give us the middle term, 12y. The other example, d squared plus 4d minus 21. Two factors of d squared will be d and d. Two factors of 21 will be 7 and 3. But here we have minus 21. So we have to know how to manipulate the signs. One must be a plus, one must be a minus. The middle term on the left is a plus. So the greater factor will carry the plus. So when we factorize d squared plus 4d minus 21, we'll have d plus 7 times d minus 3. In the third example, 3y squared plus 5y plus 2. In this case, we would be looking for a slightly different technique. The coefficient of the first term, which is 3, and the last term, which is 2, you multiply 3 times 2, you have 6. Two factors of 6 would be 3 and 2. And when we add 3 and 2, we'll get that middle term 5. So we can rewrite the three-term expression as 4 terms. That is, we write 3y squared, which will remain 3y squared, and we rewrite 5y as 3y plus 2y. The 3 and the 2 obtained from the factors of 6. And the last term of that three-term expression is 2. So we group them, and we have two groups. We have 3y squared plus 3y as one group, and the second group as 2y plus 2. From the first group, 3y is common. And if we extract 3y as the common factor, we will have 3y into y plus 1. Plus, in the second pair, we have 2 as a common factor. And if we extract the common factor 2, we'll have y plus 1. We are not quite finished. You will notice now, we have two terms still. But in the first term, you have a y plus 1, and in the second term, you have y plus 1 also. So y plus 1 is common. So if we extract the common factor y plus 1, what will remain will be 3y plus 2. So when 3y squared plus 5y plus 2 is completely factorized, we have y plus 1 into 3y plus 2. Let's look at another example. We have 3y squared minus 5y plus 2. It's a three-term expression. It's difficult from observation that you can find the factors easily. So we can expand the three-term expression to 4 terms. We multiply the coefficient of the first with the third term, that is 3 times 2, which is 6. 2 factors of 6 that will give us a 5 would be 3 and 2. And again, we have to manipulate the signs and express 3y squared minus 5y plus 2 as 3y squared minus 3y minus 2y plus 2, because minus 3y minus 2y is another way of expressing minus 5y. Grouping them, and an important principle you need to note here. In the first group, we'll have 3y squared minus 3y. In the second group, we are introducing the bracket again, noting that there's a minus in front. And when there's a minus in front of the bracket, and we want to insert the bracket, we'll have to change that plus 2 to minus 2. So the expression 3y squared minus 3y minus 2y plus 2 can be expressed as 3y squared minus 3y in brackets minus open brackets 2y minus 2 close brackets. We can take the common factor of the first group, that is 3y. So it is 3y into y minus 1 minus 2 into y minus 1. Again, for the 2 terms, you would have recognized that y minus 1 is common. And when it is extracted, we'll have y minus 1 into 3y minus 2. Here are your problems for today. Factorize completely 2p squared minus 7p plus 3. That's your first one. The second one, 5p plus 5q plus p squared minus q squared. Those 2 questions were taken from CXC January 2007. The third one, simplify a squared plus 4a all divided by a squared plus 3a minus 4. Now in this third example, you will have to do some level of factorization and then cancel the common terms to simplify it. Here are the solutions to the problems given in the last lesson. X minus 3 over 3 minus x minus 2 over 5 is equal to, we look for the common LCM, the common denominator. The common denominator of 3 and 5 is 15. So 3 into 15 is 5. 5 times the numerator would be 5 into x minus 3. 5 into 15 is 3. So it will be minus 3 into x minus 2. Simplifying or clearing the brackets of the numerator, we will have 5x minus 15 minus 3x plus 6. And note the change of sign. A negative 3 times a negative 2 will give us positive 6. So all of that must be written over 15. And if we simplify the numerator, we will have 5x minus 3x will give us 2x, minus 15 plus 6 will give us minus 9, all that over 15. So when x minus 3 over 3 minus x minus 2 over 5 is simplified. We have that as 2x minus 9 over 15. The other example, 3p over 2 plus q over p. The LCM of 2 and p is 2p. So the first fraction, 2 into 2p is p. So it's p times 3p plus p into 2p is 2. 2 times q is 2q. The first term in the numerator can be cleared to be expressed as 3p squared plus 2q, all divided by 2p. This brings us to the end of today's lesson, CXC Mathematics in Focus.
Hello boys and girls, welcome to lesson 5 of CXC English in Focus. Today we will recap persuasive writing. We have learned from the examiners who have marked this section over the years that candidates often produce weak answers because they use weak, careless grammar, because they are unable to set out and develop an argument, such as by means of a topic statement supported by evidence. They often spend too much time making one point or flit from one idea to the next, then back, thus confusing or annoying the reader instead of developing one point convincingly, then promptly moving on to the next. They fail to think out and organize their ideas, and as a result, soon run out of matter and resort to repeating themselves or producing weak, unconvincing arguments. It therefore means that you have to pay attention to the following. 1. Ensure that your sentences are written properly. The verb must agree with the subject. Be consistent in your use of tense. Make sure that you have a complete sentence and not a sentence fragment. Pay attention to punctuation. 2. Pay attention to your paragraphs. Remember that your paragraphs should have only one main idea. Remember to relate all your sentences in the paragraph to the main idea. Remember to link your ideas in such a way that the paragraph reads smoothly. Remember to strengthen your point by using persuasive techniques such as rhetorical questions, examples, statistics, emotive language, counter-arguments, repetitions, analogies, authoritative evidence, and scientific evidence. Pay attention to the organization of your essay. Step 1. Remember to begin by introducing your topic and making clear your position in an introductory paragraph. Step 2. Remember to develop each point in a separate paragraph. This section may take up 3 paragraphs. And step 3, conclude by summarizing your points and restating your position. Now, boys and girls, let us practice writing a persuasive essay. The topic is small countries like those in the Caribbean can do very little to clean up the environment. And we are going to argue that small countries can in fact contribute substantially to clean up the environment. First, you have to make your plan. So, here's our plan. Introduction. Name a small country in the Caribbean and state your point of view. Argument 1. Disposing of litter and waste in a satisfactory way can help to clean up the environment, and this is not beyond the means of Guyana. Argument 2. Guyana is in a position to ensure that environmentally friendly methods are used to exploit our natural resources. Argument 3. Guyana is in a position to promote ecotourism, which can contribute to a clean environment. Conclusion. Summary of main points in the body. The next step then is to expand on the points. So, let's do that. I disagree with the statement that small countries like those in the Caribbean can do very little to clean up the environment. Guyana is relatively small, and we are certainly poor, but we can contribute significantly to the cleaning up of our environment. Guyana's population is relatively small, so it would not be difficult to get rid of our waste and litter in a satisfactory way. Litter and waste can be easily collected from homes and institutions in highly populated areas and taken to be burnt. Some areas of Guyana are sparsely populated, and the people there have large land space, so they can easily burn their litter and waste on their own land. Guyana is blessed with natural resources such as timber and gold. Guyana's economy is not hinged on heavy industrialization, but rather on the exploitation of our natural resources. Guyana, therefore, is in a position to insist that environmentally friendly methods are used to exploit our natural resources. Recently, Guyana has been promoting tourism as a viable industry, and why not? Guyana is certainly blessed with natural beauty and has the potential for ecotourism. Guyana's waterways, forests, and savannas could be used for activities like hiking, bird watching, and canoeing, which are all activities that will contribute to a cleaner environment. Guyana is indeed in a strong position to contribute to a cleaner environment. Our small population makes it easy for us to get rid of waste and litter. Moreover, we are blessed with natural resources which guarantees our economy without heavy industrialization. Our natural beauty also helps us to promote an environmentally friendly form of tourism. And that's our persuasive essay for today. On behalf of the team, Bibi Ali, Parmeshwar Lal, Ron Chichester, I'm Ingrid Fong, saying thank you for viewing.
The National Communications Network, in collaboration with the National Center for Resource Development and the Ministry of Education, present CXC in Focus, a focus on the key subject areas of mathematics and English for students preparing to write the exams.
Welcome to our 6th lesson, CXC Mathematics in Focus. In this lesson, we will solve simultaneous equation in two variables. Here is an example of a pair of simultaneous equations. X plus y is equal to 7 and x minus y is equal to 1. X is a variable, y is a variable. X represents a number and y represents a number. So we are to look for two numbers that will make both equations true. By checking what two numbers added together will give us 7. There are several numbers that can do that. 6 and 1, 4 and 3, 7 and 0. But it must also work for the second equation. That is, when you add two numbers, you get 7, and when you subtract two numbers, you get 1. The only two numbers that can work in both situations will be 4 and 3. That is, x must be equal to 4, y must be equal to 3. So if we add 4 and 3, we get 7. If we take away 3 from 4, we get 1. So those two values will satisfy those two equations, and they are called solutions to the equation. By inspection, we sometimes can determine the value of the two variables. There are times when we use special techniques to solve the problems. Here is a technique using the principle of substitution. We have two equations to solve. Y is equal to 3x, your first equation. X plus y is equal to 12, your second equation. In the substitution method, we substitute one equation into the other equation. In this case, we substitute y is equal to 3x in the second equation. That's equation 2. And we have x plus, instead of y, we write the value for y, which is 3x. So we have x plus 3x equals 12. X plus 3x will give us 4x. 4x is equal to 12. What number multiplied by 4 will give us 12? Obviously, it's 3. So if we substitute x equals 3 in equation 1, that is the first equation there, we have y is equal to 9. That is, y is equal to 3x. So if we substitute for x3, we will get y is equal to 9. The solution to the pair of equations is x is equal to 3 and y is equal to 9. You can use these values of x and y to substitute in equations 1 and 2 to verify the correctness of the answer. For example, solve 2x plus 3y is equal to 7, first equation. 3x minus y is equal to 5, second equation. Solve for y in equation 2. It's easier to pick up y from equation 2. If you solve for y in equation 2, or you make y the subject of the formula for equation 2, we will have y is equal to 3x minus 5. Call that our third equation. Substitute the third equation, which is equation 3, in equation 1. We have 2x plus, instead of y, 3y, we write 3 into 3x minus 5 equals 7. So the first equation can be written as 2x plus 3 into 3x minus 5 equals 7. We have one variable there. So if we simplify the left-hand side, we'll have 2x plus 9x minus 15 equals 7. 2x plus 9x will give us 11x. Transposing minus 15 to the right will give us plus 15. 15 plus 7 will give us 22. So the equation can be simplified to be 11x is equal to 22. 11 times what number will give us 22? Obviously it is 2. So x is equal to 2. Substitute x equal 2 in the third equation to find for y, because y is equal to 3x minus 5. So when we substitute 2 for x, we'll have y is equal to 6 minus 5. 6 minus 5 is equal to 1. The solution to the equation would be x equal to 2, y is equal to 1. Okay, you can verify the correctness by going back to equation 1, where you have x, you put 2, and where you have y, you put 1. So 2 times 2, which is 4, plus 3 times 1, which is 3. 4 plus 3 is equal to 7. Try the same thing with the second equation. 3 times x, which will be 3 to 6, minus y, which is 1. 6 minus 1 is 5. When we have those two values, we can always verify and know before the examiner marks your paper whether your answer is correct or not. You can do your own verification. And if you're not balancing, it means you have to check back the steps in your working. Steps to follow when using the substitution method. There are 4 simple steps, and we can add on the 5th step to verify the answer. The first step, solve one of the equations for one of its variables if neither equation is already solved. The second step, substitute this value in the other equation. The third step, solve the resulting equation for one of the variables. The fourth step, find the value of the second variable by substituting the result obtained in the other equation. And the last step is verification. That is, you're testing to see if your answer is correct. Another method that is commonly used to solve simultaneous equations is the elimination method, in which one variable is eliminated algebraically to combine the two equations into one simple equation. Let us apply it to one set of equations solved just a moment ago. 2x plus 3y is equal to 7, our first equation. 3x minus y is equal to 5, our second equation. Multiply the second equation, or equation 2, by 3 and add it to equation 1. Equation 1 can be rewritten as 2x plus 3y equals 7. And when we multiply equation 2 by 3, we have 9x minus 3y is equal to 15. Call that our third equation. We try to do that to ensure that we can have common coefficients either for x or for y. So by adding or subtracting, we can get rid of one of the variables. In this case, if we add, we will have 9x plus 2x equal 11x, minus 3y plus 3y will give us 0, so the y has gone. 15 plus 7 will give us 22. So 11x is equal to 22, x is equal to 2. Substitute x equal 2 in equation 1, we have y is equal to 1. Hence, the solution to the equation would be x is equal to 2 and y is equal to 1. Here are your problems for today. Solve the simultaneous equations. 5x plus 6y is equal to 37, and 2x minus 3y is equal to 4. That question is taken from CXC January 2006. Another question: solve the following pair of simultaneous equations. 2x plus 3y is equal to 18. X plus 5y is equal to 23. That one is taken from CXC January 2004. There are other methods to solve simultaneous equations. These include the matrix method and the graphical method, which we will reach in a subsequent lesson. And now the solution to the problems in the last lesson. Factorize completely. 2p squared minus 7p plus 3 can be rewritten as a four-term expression as 2p squared minus 6p minus p plus 3. Grouping them in pairs, we'll have the first pair factorized as 2p into p minus 3. For the second pair, minus 1 is common, which will give us minus 1 into p minus 3. And you'll recognize that p minus 3 is common, so we can extract the common factor, and the expression can be factorized completely as p minus 3 into 2p minus 1. The second one, 5p plus 5q plus p squared minus q squared, we can have groups in twos. The first pair, you would recognize the common factor 5, and so the first pair can be written as 5 into p plus q, plus the second pair you will recognize as difference of two squares, and so the square root of p squared would be p minus square root of q squared, which is q. We repeat that but change the sign from minus to plus. So p plus q is common, and hence if we extract p plus q as a common factor, we'll have p plus q into 5 plus p minus q. The exercise where you're asked to simplify this expression. If we factorize the numerator, we'll have a into a plus 4. If we factorize the denominator, we'll have a plus 4 into a minus 1. In the numerator, you see a plus 4 as a factor. In the denominator, you see a plus 4 as a factor. Those two factors can be cancelled, and we'll end up with a result a over a minus 1. This brings us to the end of today's lesson, CXC Mathematics in Focus. Welcome to lesson number 7, CXC Mathematics in Focus. In today's lesson, we'll be looking at quadratic equations. A quadratic equation has one variable whose highest power is 2. Here are two examples of quadratic equations. X squared is equal to 16. Another example, x squared plus 5x minus 6 is equal to 0. In solving a quadratic equation, we will have two possible values for the variable. These are called the roots of the equation. To find the roots of x squared is equal to 16, we look for a number x when multiplied by itself will give you 16. There are two such numbers, plus 4 and minus 4. Hence, the roots of the equation are